Okay, my name is Scott Gerard, and I'm a certified data scientist. And what I wanted to cover today was to talk a little bit about how you can get started with AIoT in your own development projects. And AIoT is short for artificial intelligence of things. So that's what we're really going to focus on here. And that's what the main message I'm trying to get across here. So let's take a look at how I perceive a lot of these development processes are going to take place. Um, it really requires a whole lot of skills, and just writing these all down was kind of surprising. But to do a project like this, and to develop it and produce it, you're going to have to understand your business model. You're going to have to do the business development to make sure it sits with your clients. You want to look at how they deal with your investors and how you're going to do marketing and sales. And there's a whole lot of skills just in doing this business part of it. But you've also got to build hardware, right? And so there's skills involved there. What are you going to do for packaging? How do you do the power? How do you do the mechanical, the electrical, the sensor designs and the sensor implementations themselves, thermal considerations? And of course, security is a main piece of this that has to be considered as well. So there's a bunch of skills there. Then you've got to do some networking to get the data from the sensors off to somewhere where you can do something with it, but that's another set of skills. And then you get to the software itself, the compute platform. How are you going to do the software development, the user interface design and user experience design? You may need some DevOps. Maybe you're doing some container building and you've got to make sure you're doing that correctly. Think about the security of the software part of this as well, and how does it affect the hardware security? And then there's the whole edge versus cloud kind of debate, and we'll talk about that some as well. I expect, and for most of my clients, this is like a 1 to 2 year project to start from ground zero, to take care of all of these things and to get all of this stuff done. And we've already touched on all kinds of skills. But you've now got the data somewhere. What are you going to do with the data? How are you going to get insights from that data? And I think one of the most interesting technologies to provide insights out of data is artificial intelligence. But this is bringing in yet more skills. Statistics, experimentation, feature engineering, certainly machine learning. Maybe you've even got some image, video, or natural language processing going on. Maybe you've got ethics in there as well. But to pull all of this together requires a lot of people with a lot of skills. But it's really the AI piece itself, I think, that provides the ultimate value to your client. All of these pieces are required. All of them are essential. But AI is really where you see that value really blossom into something that you can sell well. Just a little bit of terminology here. For some of you who may not be as familiar with some of these terms, I think a lot of people are kind of confused, and it's like, well, there's artificial intelligence, and that's kind of like machine learning, and it's kind of like deep learning. They're all kind of seem to be the same. I don't really understand the difference. That is not the right picture that you want to have in your mind. And if you look at just the amount of press coverage, well, deep learning has had huge press coverage recently. And I think a lot of people are saying, well, machine learning is some kind of piece of that for sure. And then I'm not really sure where AI fits into this whole thing. But, this is kind of the picture of that's true, right? Well, that's also not true. The real reality is this. AI is this big, huge umbrella that encompasses many things. Machine learning is one of the areas of that. I'll talk about that in the next slide. And then deep learning is a piece of that. So, the press doesn't actually give you a good picture of the relative importance and the relative relationships of these terms. So AI has been around since the 50s and the 60s. It encompasses a lot of different things. Back in the 50s and the 60s, everybody thought that formal logics and formal reasoning was the way forward. This led to basically theorem proving kinds of approaches. And there was a lot of work done here. There's still active work being done there, but it doesn't get much press. But this is one area of artificial intelligence that's worth understanding. The next area is what I call perception. I'm given something like an image, and I've got to figure out, oh, that's an image of a cat. Maybe I'm looking at video. Maybe I'm looking at audio, and I'm trying to extract out words from the audio. Maybe I'm looking at LiDAR or radar, and I'm trying to figure out what's in there. Perception is one whole area of artificial intelligence as well. The next one here is knowledge representation. Here we're talking about taxonomies, we're talking about ontologies. How do these different terms that I know relate to each other? What's that all about? That's another area of artificial intelligence. Planning, I'm at point A and I want to get to point B, and I think it's going to take me about 10 steps to get there. What steps do I take? What order do I take them there? How do I weave them all together? Planning is a whole another area of artificial intelligence. These two are kind of the similar. I call them agents, although if it's purely a software agent with no embodiment, I think of that as an agent, but it's purely virtual. If I want to give an embodiment to that, and I want to put it in some kind of a physical container, now we're talking robotics, but there's still a lot of similarities between parts of these two things here. The next one is natural language processing. The whole Chat GPT explosion is an outgrowth of this NLP processing. It's a whole subfield of artificial intelligence of its own. And then the last one here is machine learning. This is where machine learning is a part of artificial intelligence. Now, just to kind of help maybe relate how are they related to each other, I like to think that AI is to machine learning as science is to mathematics. Just about every field of science uses mathematics these days, and just about every field of artificial intelligence uses machine learning. But physicists and chemists are different than mathematicians. Yes, there is some overlap. They do some similar things together, but there is kind of a nice distinction between the two. I think the distinction between AI and ML is a little fuzzier, but I think if you put that kind of a picture in your mind, it'll help you understand kind of how machine learning and AI relate to each other. Also, machine learning is a lot exploratory and a lot experimental. There isn't standard cookbooks that if you just follow this recipe, you're going to get, down to success. We don't understand what the data looks like always. We need to understand some of these things, and you don't understand it until you get going further. So there are some exploratory and experimental things, which means you don't really know if it's going to work until you actually get it to work. I also want people to understand that this machine learning isn't deterministic. It's not right or wrong. You can do very useful machine learning algorithms that only give you 70% accuracy. Obviously, you would like more, but you can get by with 70% in some situations. And I'll just tell you, I've never seen a machine learning application in production that ever achieved 100% accuracy. So if you think that's what you're going for, you need to adjust your expectations somewhat. So what is data science? What is that about? I think, to me, that is the profession or the practice of applying AI and ML to analyze problems. So it's just a professional statement. It's not the technologies themselves. So let's talk first about where do you start on this kind of a process? And my recommendation is to start with the end in mind. Start with the value in mind. Start there, because if you can achieve that, then you'll actually have something of value. And once you have that, then work backwards from there. Don't start at the front and work forward. That's the classic engineer approach of, gee, I have this cool technology, let's see what I can do with it. But you often end up in a place where you don't have anything real value. We want to start with the value and then work backwards into what analytics will give me that value. Can I actually have analytics that will do that? And then once I know that, what data do I need to have to drive those analytics, and how can I get that, or do I actually have that? So start with the end in mind and work backwards. And that's what we're going to do in this presentation as well. So how do you do your use cases? I think a large part of this is brainstorming. There are a number of techniques that kind of help you structure a brainstorming session. I've used design thinking in the past. I think it's a great approach, but it's just one of many. But brainstorm some possible ideas. Think outside the box and get some new ideas going. Within that, there's a couple of ways to dissect this thing that I think may make it easier for people to approach. I like to think of some of the ideas as being either efficient or innovative. Efficiency is when there's something I'm doing today. I want to make it cheaper, faster, less waste, more accurate, whatever. I have something I'm doing and I want to make it better. Those are the efficiency use cases. The other side are the innovative ones. I'm not doing this at all today, but wouldn't it be cool if I could do X or if I could do Y or Z? This isn't a hard and fast difference between them, but kind of thinking about your ideas in those terms might help you achieve some better brainstorming. A lot of people think, I want to do some AI that's going to help my clients because I want to provide value to my clients, but I also want to generate some, positive brand for my own brand here. I want to improve that. I want to show my customers that we're on the leading edge here. And that's great. But every business has lots of processes. And maybe what you want to do is apply some AI to some of your internally focused things. I want to improve how I do supply chain. I want to improve how I do marketing. I want to do some of those internal things. The clients may not know that very well, but that's what you want to do. So that's another way to kind of think about how to generate some new ideas for brainstorming. And then also there's the time scale that's involved. I'm working with a client now. They're interested in how close is a person getting to a large piece of machinery. And the closer they get, the more dangerous or precarious it becomes. If they get too close, I might want to send an alert to the person immediately saying, you're too dang close, back away from that machine. I don't want an accident here, right? That's on a very immediate sort of a time scale. But at the other end, it's maybe what you're interested in is these near miss events, and I just want to count them. Did I have more near miss events this week than last week? Am I doing better? Am I doing worse? How can I improve it? It's a metric I want to track. So it's basically the same use case, but different kinds of ends in mind. And of course, you also want to understand and define what success looks for you. How do I define the value that I'm trying to provide, and what KPIs or metrics can I put in place that will help me achieve that? And finally, it's really good to tell a story. We're humans. Humans react well to stories. And the story is not just for your clients, but tell the story to your investors to make sure that they understand kind of in the big picture, and usually with a little bit of an emotional connection to it as well, what's going on. But you also want to tell your employees that, so everybody in the development shop is on the same page. But you also want to tell it to yourself, because that will really help you achieve what you're trying to get to. I generated this picture because I was working with some clients, and one of the guys, bless his soul, he had some things that he was doing today. And he was like, can I just add a little bit to this? I don't know quite how to do it. Maybe we can add some AI to that, and that'll help. And he was really good at generating a bunch of ideas that were just very incremental in nature. But the farther away we got, the less incremental, the more expansive we got, the fewer ideas he had. Kind of on the other end of this spectrum is what I call the Mars shot. A lot of people talk about moonshot, projects, but if you're Elon Musk, you're going for Mars. These are the expansive, really complex, totally innovative ideas. What I like to think of is this is the idea that we want to build commander data from Star Trek, right? That's what I want to build. And once I have that, then I can do all these cool things. And that's great. It's really easy to come up with a lot of these values as well, or these use cases as well. But it's hard to find some of these that are kind of in the middle. But my experience is the value looks like this. If you've got an incremental use case, sure, it can provide some value, but it's not going to provide as much as you get into here to the middle. The Mars shots ideas, unless you're Elon Musk, don't go there. Nobody knows how to build commander data. I think that's just got absolutely zero value in today's environment. But some of them, they do have some value. But again, it's this middle area here where I think some of the biggest value is. So how do you find those? I think what you really need to do is to find somebody on your team that understands this data science, machine learning kind of world, and have them help you with that. Or if there isn't anybody on your team, go externally and find somebody that can help you with this kind of stuff, because these are the ones that are the hardest to find, but the most valuable. So let's say you've gone through this exercise and you've come up with 5 different use cases, or maybe 10, or maybe 15, or maybe 20. Let's plot them on this is a design thinking grid. They call it the prioritization grid. Here on the x-axis, we have on the low end of the feasibility these things are just basically unfeasible. We don't know how to build them. It would be way too expensive to build them. It'd take $1 billion to build them, whatever. And then on this high end over here, these are the ones that are really easy to build, right? The y-axis is the value, the high value on the top. Just kind of generally plot your use cases on this. It doesn't have to be exact, but once you've put them in this kind of a grid, the ones up here are the no-brainers, right? They're super high value and they're really easy to build. That's where you probably want to start. The ones over here, don't go there. They're either very difficult to implement, or they have very low value, or some combination of them, but they're just not good use cases for you to start with. The interesting second tier ones, I think, are kind of interesting. The big bets ones, these are challenging to build, but they've got a lot of value. If you can figure out the challenges for the feasibility, you'd be in a good position. And then these utility ones down here are really easy to build. They have kind of a medium level of value, but they can also be really helpful as well. So kind of plot them out on this grid, start with the no-brainers, work into this second tier, and just kind of ignore the third tier. So now you've got your use cases prioritized in a way that you can begin to think about them. So we've done the use cases. Now we're backing up to the analytics. There's really too much in the analytics to really cover here in any real depth, but I wanted to give you a little bit of a flavor of what's going on. There's four basic types of machine learning. This first one is supervised learning. So we've got these data points and we're trying to classify them as good or bad, true or false, accident, non-accident, whatever your attribute is, we're trying to classify them in that sort of a way. And the goal of the machine learning is, and by the way, once you've done that classification of good versus bad, that's called ground truth. You're telling the machine learning algorithm, these are good, these are bad. Now go find me a line, find me a plane that helps separate those use cases. And that's really what the machine learning is doing. So now that if I get a new point that I've never seen before in this area, I can say it's a blue point. If you don't have ground truth, then the best you can usually do is what's called unsupervised learning. And this is really taking your data points and clustering them together. So I'm trying to build a cluster of data points that are close to each other, but far from all the other data points. And once I've found these clusters, someone goes in and kind of tries to summarize the clusters. And that's usually a very valuable thing to do. And that's a different kind of machine learning. This third case is called dimensionality reduction. And in this particular picture, it shows that I've got a bunch of data points in 3 dimensions, and then I'm going to project that data onto one of these 3 planes here. And by doing that, I've reduced some of the data. I've taken one of the dimensions out, and I don't have a completely full picture of what's going on, but I have a good idea what's going on. I've still got a number of dimensions left. And maybe I can understand what's going on in this reduced dimension space. Now, in reality, you're not going to start with 3 dimensions. You're going to start with 10 dimensions or 100 dimensions or thousands of dimensions. And you're going to reduce it down to some smaller number of dimensions. But this is one way to help you understand what's going on in your data. And a lot of data is very high dimensionality. The last case is reinforcement learning. This is a more challenging area for sure. I would suggest that you think about games like the game of chess. In the supervised learning, I have one data point, I have one piece of ground truth. If my model doesn't give me that value, the machine learning algorithm helps change the model to try to make sure that each data point gives its ground truth value. Not for everything, of course, but that's the goal. But for every data point, I get feedback on whether I was right or wrong. In reinforcement learning, in a game of chess, you'll play on average 40 moves before you find out whether you won or lost the game or not. So the trick with reinforcement learning is to take that win or loss information and propagate it back to those through those 40 different steps and figure out which steps were good and which steps were not good. So we did the use cases, we backed up to the analytics, and now we're backing up from the analytics back to the data. I like to think of this in terms of the V's, and it's called that because all of the words here begin with V. It's just kind of a nice little mnemonic. Different people have different numbers of V's. They have different sets of V's in them. These are the ones that I kind of think are pretty good to start with anyway. You can add your own if you want, but the first one is variety. Data comes in different kinds of varieties. The one kind is structured data. So think tables, spreadsheets, relational databases. Each piece of data can be quickly and easily isolated to one part of the data set. I can go point at each piece of this data pretty easily. And structured data is the easiest thing to work with. Then I have semi-structured data. It's a little more complex. Think JSON and XML. Some of the data values are pretty easy to find. They're tagged as such within there, but there may be other parts of the data set that aren't tagged and are harder to extract data attributes from, but some of them are easy. So that's kind of semi-structured. The last one is the most challenging, of course, which is unstructured data. Here's a blob of text. You go figure out what the attributes are from this text. Here's an image. You go figure out where the people are in that image. Same thing for video, LiDAR, radar images. The unstructured is a much more challenging piece of data to consider. But what you want to do is look at your data set or data sets and understand what kind of variety that data set has. The next two are volume and velocity. How much data do we have? Kilobytes, gigabytes? How quickly is it coming at us? Is it coming every second, every minute, every day? So those two kind of go together, but you want to understand how much data you're going to have to deal with, and that would in part makes a distinction on what kind of compute you're going to have. The next attribute is veracity. How accurate is the data? What's the quality of it? Is it complete? Do you have gaps? Is it accurate? Do you need to calibrate it? How well can you trust the data you have in there? And this could be different for different data sets. I added this venue in here. It's really more of a processing location, but where am I going to process the data? We'll talk about that in the next slide some more. And then the last one is value. This can typically be a little trickier to analyze up front. It's usually more at the end where you understand this, but I'm looking for a particular piece of value. Does this data even have the signal that I need to provide that value? If it doesn't, you're dead before you get started. But try to understand, does the data contain what I'm looking for? So here's a little bit about the compute venues. So if you're, any one of the other machine learning kinds of people, you're probably going to push all of your data to the cloud. You're going to do your analytics and machine learning up there, and that's great. For AIoT, we still have that option as well, but we have other options. This option is the on-premise data center. And by the way, this is a graphic I took from the LF Edge X guys. I thought this was a really descriptive characterization. But this on-prem data center edge, this is probably within meters of your sensors, but you could do some analytics on this on-prem data center edge. But there are other options as well. Now, these two really work well for the telco industry, but I might have a regional edge or an access edge. The regional edge may be within a few hundred kilometers of the sensors. The access edge is probably within a kilometer or so of it. Think telephone poles, wireless towers. You could put compute there and analyze some things there. Not all of us are going to have access to that kind of centers, but some of you might. And then we can take this on-prem data center edge and maybe push compute closer and closer down to the device. And you can push that as far as you want. But we have all of these different options to consider. We probably won't use all of them, but we can consider all of them. But what this really then begins to come up with is distributed computing. What analytics do I want to run on each of these different platforms? And then how do they talk to each other? How do they share data with each other? There's another layer of consideration there of how to best use this. Obviously, the low latency is on the left and the really high compute is on the right, but there's a lot of options here. And to me, this is kind of one of the defining characteristics of AIoT. There's a lot of options here that we have that other people don't typically have. You're building your data, you're building your IoT device, but it's still early and you don't have anything that you can run. How can you get data to play with before you have the device? Well, we can do some synthetic data generation. This is another area that is not as well known, but it's certainly plausible and possible to do this. So this is generating synthetic data before you have real data. And if you had synthetic data, then you could begin to build your ML models before you have real data, and you could see how well things are shaping up there. The one thing you want to do, one of the things you want to do is you want to make sure that the data that you're generating satisfies multiple distributions. And this is a little more complicated to explain, but really simply, if I'm generating data about a person, I want to make sure his age is at least as great as his years of experience. If I generate a person with 40 years of experience that's only 20 years old, that doesn't make any sense whatsoever. So there's relationships between the various variables that you want to maintain or enforce. And this will get us into a bunch of probabilistic models. I don't have time to really go through that here now, but that's one way to generate some data that looks pretty good. Another interesting thing is, since I'm generating synthetic data, it's not real data. So this data doesn't need to be anonymized. It is already synthetic. It is already anonymized. And I can either generate that data from the get-go, or there's actually techniques that if I do have real data, I can generate synthetic data based on that has all the right distributions. And that gets us into the whole case of machine learning with deep learning models called autoencoders. It's a really interesting area. We'll have to leave that there for now, though. So great. You're a small or medium company and you're trying to get started with this. How do you do this? What do you need to think about in terms of your team? Well, to get started, you need a domain person that understands the domain you're working in, that can help keep you on track, that these things are important and these things are irrelevant. You're certainly going to need some hardware people. You're going to need some software people. And you're going to need some data scientists at some point. I've got this with a dashed line because exactly when they come on depends on the particular project. But you're going to start small. And then over time, you're going to branch out and you're going to begin to pull more people on, and you're going to have more specialized skills. Like the domain guy is going to say, hey, this is getting too much. I need a manager to help me out. And then the manager is going to say, well, I'm taking care of all the people, but I need a program manager to happen with the project development kind of stuff. And the same sort of a thing happens with all of these technologies. And in the end, you may have a number of people over here that you need to build a project. The one that I wanted to highlight is the data scientist. I think you want someone in here at early in the project, but not necessarily full-time. They won't become full-time until later. But that's one of the things to kind of think through. But start small and add the people that you need when you need them. So what's so special about AIoT? Considering all these things, what is AIoT and how is it different from other kinds of machine learning endeavors? I think because the data is being generated by sensors, mechanical devices, you can have a high volume of data and a high velocity of data. So you can have data coming at you every second if you want, and you could generate a lot of data in a hurry. Other people, maybe not so much. Typically, the data that the IoT devices are generating are structured variety. You may be pulling in some unstructured or semi-structured devices. data sets from other external data sources, but you're typically the devices are generating structure. The veracity is usually pretty good. You know, people aren't typing these values in. We're not asking people's questions and they're making up answers as they go. You've got sensors that are making physical measurements and the veracity is usually pretty good. But maybe it's not calibrated. Maybe there are dropouts that you lost connectivity with the device, and so there's missing data. But typically the veracity is pretty good. We talked about the distributed computing across the multiple different venues. I think that's one of the special characteristics about AIoT. There's a lot of options here that can make it more complex, but also can make it much more valuable. And, you know, just to get the value out of it, we talked about a little bit already, but maybe you need to combine multiple data sources together to get enough context to really show you the value. If you've got temperature, pressure, and humidity, that's great data, but you may need some weather prediction data to really begin to make that give you value. So then there's some pitfalls here. So these are some things that I would ask you to think about to make sure you don't get into trouble. And you certainly want to think about them early and often. IoT cybersecurity, this isn't really an AI technique or a problem, but man, I think this is a really important thing. And we all need to be really cautious about the cybersecurity aspects of these devices. If we get hacked, bad things can happen, and you need to understand what some of those bad things are for your particular project. But back on the kind of the AI ML side, I think it's a pitfall, a potential problem if you're not considering your final AI ML use cases early enough. You want to consider them early on. You may not have to implement them early on. You may not do a lot of work early on in them, but you want to make sure you understand what your roadmap is and where you're going, and to keep those concerns in as the project evolves. One of the things that you can do that would cause that is you don't have enough sensors. One of the projects I worked on personally is we specifically attempted to over-sensor our environment. And the thought was that at the end of the analysis, we would, compute it with all the data, and then we would begin to drop out sensors and retrain and see how the analysis worked and try to figure out the sweet spot. How many did we actually need? But we could over-censor it so we could find out what that sweet spot is. We specifically tried to over-censor, but we under-censored. We just didn't have enough data at the end of the day to do this. So even though we were trying specifically to address this, we still didn't do a good enough job. The other thing is, do you have the right kinds of sensors? If you build a device that has a temperature sensor, but you really need temperature and pressure, that's not a good thing. You may be looking at another 2-year development cycle to try to get the right set of sensors on it. So these two things, if you know exactly what you need, that's fabulous, but I would recommend that you over-censor both in terms of numbers and in terms of kinds of sensors rather than under-censor. I realize that there are financial implications to all that, but it's better to overdo than to underdo. You also want to consider your sense to compute latency. How close does the compute have to be to the sensor to get the kind of capabilities that you want? Because if you have to go all the way to the cloud and back, that's going to be a lot longer than if you're doing something very close. This was another rookie mistake that we made. You don't want to saturate the bandwidth. We had a project where we put like 700 different Wi-Fi sensors on one floor of a building. And looking back, it was kind of obvious that we could totally overwhelm the Wi-Fi, and we did. So we had to pull out sensors to make the Wi-Fi work again. So that's another area that you want to consider early on. I also think that you need to make sure that you have some kind of a device management capability. If you've got hundreds of sensors deployed, it's too painful and too expensive to go around and physically touch each one of those sensors multiple times. You really want the software to be able to pull that information together into some kind of a central place so you can see what's going on. You need observability into all of your sensors. The easy one is which ones which devices is the battery about to go out? And you want to be able to see that and to know where they are, right? But not only that, you also want to just not observe them, but you want to be able to push software down to them. And that is both for cybersecurity things. We found new problems that we want to fix, and I want to be able to push software back down to the devices to make them more secure, but also your machine learning models. The models will evolve over time by themselves. And that could either be because you're getting smarter and you're getting more accurate about it, or perhaps the data that you trained on is not quite the same as the data that you're using in production. And you want to update the models to deal with the real production data that you're seeing. So that's one reason why you want to be able to do over-the-air updates or some kind of an update capability. And you also want to be aware of the emerging legislation. You know, a number of years ago, we didn't really care about this, but GDPR came on the scene, and there are now requirements that you must address to be GDPR compliant. California Consumer Privacy Act is another one. Brazil's got stuff, and legislatures around the globe are coming up with new and more constraining requirements that are being placed on various forms of data. And you want to make sure that you're not getting yourself into trouble with that. One particularly interesting area that's just kind of a minor point here, but what are your user agreements? Do your user agreements allow you to use the data you collect from your users to do the kind of analytics and the processing that you want to do? If you start out in the beginning with, very open, very vague user agreements, it's going to be kind of embarrassing to have to go back and say, yeah, I know you signed this agreement, but now we need you to give us authority to process your data, to store your data, to analyze your data. So just think about that early on as well. So what does a roadmap kind of look like? This is generic, of course, but I think it's very useful. So in the beginning, you want to look at your use cases, and not only from all of the hardware and the software aspects and the business aspects, but you also want to be sure that you're including the AI ML aspects in this to make sure that you've got a plan, a roadmap that you believe is going to lead you to success. While you're building that device, there will be design changes. It will evolve. And I think you need and want someone with these AI ML skills as part of the evaluation of these changes. Just as you evaluate the hardware changes and the software changes, you want to evaluate how they might affect the AI as well. If you're interested in that, maybe you can generate some synthetic data, and you would be doing this probably before you have real hardware that's generating real data. There are techniques that we can use to do that. And then at some point, you're going to get to the big thing here. We're going to build an ML model. This is usually a bigger development effort, but how do I build a model to generate the value I'm wanting to do? If you have to wait until you get real data, it will certainly be later in the process. If you're using synthetic data, you can move that forward some, but what is the ML that you're actually going to build? And then finally, when you're in production, is the data that you trained on similar to the data that you're seeing in production? Are you monitoring that? Are you seeing how far apart they are? Are you deciding at some point it's drifted too far, the production data has drifted too far and I need to go do something? This is where the production monitoring kind of comes in. And then finally, I've kind of alluded to this a number of times, but I think you want someone on your team, maybe only fractionally, but that understands data science and understands some of the concerns that are going on. Most small and medium businesses, I don't think, can afford a full-time data scientist, and I don't think they need a full-time data scientist. They will in the later stages, but not early up front. But it's good to have somebody that you can tap and trust that understands some of these things, particularly for the use cases and the design changes that have the evolution there that can help you get through some of those and make sure that you're not wandering off the path. So I definitely recommend you find someone that can help you with that. So in conclusion, I recommend that you start with the value, start with the use cases in mind, and then work backwards, right? So we've talked about the use cases, do some brainstorming. Once you hit that and prioritize them, back up into what analytics are you going to need to do that? And you'll probably need help from that. And then once you have the analytics in mind, what kind of data do you need to drive that? And is your device providing the data that's going to drive those analytics to give you that value? Talked a little bit about team evolution. Start small and add the people that you need if and when you need them. And then finally, we talked about some of the AIoT specific concerns. Now, I know this is all virtual. There's not time for questions in this format, but thank you for listening. And if you do have some questions or want to continue the conversation, here's my email. Please reach out. I'd love to continue the conversation with you. Thanks so much for listening.